Okay, so before I begin, just let me give a brief about this title what I've given, WBR STR 001. So many of you are knowing that we initiated live technical discussion series on different topics, and after that we also launched online courses on the specialized subjects. Now, recently we have received a request from a few engineers that it is better that we arrange some kind of a talk on the specialized topic. Let's say it's just only 1 hour talk, or let's say 1.5 hour of talk. So it is different than live technical discussion series and the online courses what we are doing. So what they were asking for, that we can have more focused discussion on the specialized topics, or let's say where industry is facing difficulties. And this is the question which we have received from the specific group of engineers, and we have selected this topic. So our regular live technical discussion series will continue as it is going. So we are planning aggressively numbers of sessions on that. So as you may be knowing, now we have planned session number 42 on UHPC, which is scheduled on 28th April around 4 p.m. So we are also experimenting with the time again based on your feedback. And the courses are also going on. So as we move forward, we'll be having the WBR STR 001, 002, 003, and we will be always seeking your valuable feedback for this kind of topic, on which we can have a specialized talk, or let's say we can have more focused discussion. So this is the question which we have received, IS 800 2007 or MBMA. So how we are going to approach today's talk? I have prepared a small presentation which may take around 25 to 30 minutes. So quickly, I'll just run through the presentation, and I'll share my thoughts on this important subject. And thereafter, we will be having open discussion wherein we will invite all engineers to participate in the discussion. Okay. So this is the question, IS 800 2000 or MBMA. And these are the set of questions we received from the engineers. So few of them are mentioned here. Like, can we use MBMA instead of IS 800 2007 for design of structures? Is design using IS 800 2007 uneconomical? If IS 800 2007 to be followed, then can we ignore section 12 of the code? Who will take a decision for codes or standards to be followed in the project? Who is responsible in case of any unfortunate event of collapse of the structure? And how far it is a good practice to design the structure by using American standards? And many more questions we have received. So while I am quickly running through this small presentation, I'll request you to share your points in the chat. So those points we will take up sequentially after finishing up this presentation. So please feel free to put up as many questions, as many doubts, or experience, whatever you want to share, through the chat. So first of all, what is MBMA? So if I talk about myself, I came to this terminology around 2013 or odd time. Before that, I heard this term, but I was not knowing what is MBMA. So first, let us try to understand what is MBMA. So as we all know, MBMA is the full form of Metal Building Manufacturers Association, and was founded in 1956 and promotes the design and construction of metal building systems in the low-rise non-residential building marketplace. These I have taken from the preface of MBMA document. What it says, that use of this manual is totally voluntary Each building manufacturer or designer retains the prerogative to choose its own design and commercial practices, and the responsibility to design its building system to comply with applicable specifications and safety considerations. So it's a voluntary to follow this document. It's not compulsory. That's what it's trying to say, right, in the preface. Now, in the preface itself, this is the disclaimer which is mentioned in the document, that MBMA expressly disclaim all liability for damages of any sort, whether direct, indirect, or consequential, arising out of the use, reference to, or reliance on this manual or any of its content. So this is the disclaimer which is mentioned in the document, and it doesn't take liability of any consequence, or let's say any damage arising because of the use of this manual. So this is the disclaimer put up in the preface of the document. Now, when we talk about MBMA, this is one more question we received, that which is the latest document. So latest document according to me is 2018 MBMA manual. So in this, the MBMA manual is revised substantially. There are major revisions made. Earlier documents were in 2006, 2012. So all those MBMA documents are now superseded. Latest document is MBMA 2018. And one more major update is that in 2019, MBMA has issued seismic guidelines. So it is talking about earthquake resistant design and detailing of steel structures. Okay. So if we quickly talk about what is there in 2018 MBMA document, again, this is the extract from the preface of MBMA document. It says that the most municipalities in the United States have now adopted a building code. In the past, where a building code did not govern the design, the recommended loads in the MBMA low-rise building systems manual were often specified. In recognition of the decreased need for MBMA loads, the metal building systems manual now focuses on how to apply the loads specified by the International Building Code and ASC 7. So what it is trying to say, in a sense, that earlier the most municipalities were not adopted a building code. So at that time, the loading details, or the type of loading, or let's say the loading calculations, were specified in MBMA. But now in the recent document in MBMA 2018, now it is focusing on how to apply the load specified by the different international code, or which is IBC, International Building Code, and ASC 7. So now it is talking more about implementation of IBC and ASC 7 instead of specifying the load details itself in the document. And one more thing regarding MBMA 2018 edition. So 2018 edition of the MBMA metal building systems now brings the manual into conformance with the 2018 edition of the International Building Code and ASC 716. Okay, so that's what we just discussed in the preface also. Now this is interesting. What is a 2019 document? So in 2019, seismic design guidelines were published for the metal building system. And what it says, again, in the preface of the document, the design recommendations in this guide are based on the IBC 2015 American Society of Civil Engineers, Structural Engineering Institute, ASC or SEI 710, okay, and standard industry practice. Notes are also provided to point out differences in the 2018 IBC, ASC 716, and AISC 36016. An appendix also includes now resource information on new research and recommendations. And this publication now focuses on the allowable stress design. And also it is pointing out the differences or advantages of LRFD method. Yeah. So this is the essence of MBMA 2019. So it is talking about earthquake resistant design and detailing aspect with respect to the different standards which are mentioned in this para. Okay. So with this, what is MBMA? So according to me, it's not a code or a design standard. It is just a guideline. Okay. So now, whenever we talk about the design of industrial or let's say PEB structure in India, then this is the typical hierarchy we can say. One is the owner, then there is a owner's consultant, and there is a PEB manufacturer. So typically owner will appoint owner's consultant, which is a structural consultant, and the structural consultant will prepare the tender specifications, and after preparation of tender specification, the PEB manufacturer will be shortlisted based on the techno-commercial evaluation. This is the general or typical cycle in the projects, right? Now we have talked a little bit about MBMA. Now let's also talk about IS 800 2007. So as we know about IS 800 2007, this standard applies to general construction using hot rolled steel sections, joined using riveting, bolting and welding, and specific provisions for the bridges, chimneys, cranes, tanks, transmission line, towers, etc. For all these details, we need to refer separate codes. Okay. So as we discussed about MBMA, that which is the latest document. So for IS 800 2007 also, first let's try to understand which is the latest document. So as many of you may be aware that for IS 800 2007, one amendment was issued in 2012. That's the only amendment. And thereafter in 2016, improvements were made in NBC. And what was done in NBC 2016, the entire IS 800 2007 was reproduced along with this amendment number 1, as well as there are improvements made in NBC 2016. So with this, NBC 2016 is the latest document for design of steel structures in India as of today. So with this, whenever we are preparing a tender, maybe for PEB or for the other structures related to steel structure design, then we must specify NBC 2016 because IS 800 2007 is not yet updated with respect to the improvements which are made in NBC 2016. And there are many improvements made in NBC 2016. So I would recommend that you please go through it if you have not yet gone through it. And if you have any further questions on this, we can discuss it in detail. Now, the important question, like why we should follow Indian standard codes for design in India. So here I have put up my thoughts on that. Firstly, in case of any unfortunate event of collapse of structure, there may be legal complication if IS code is not followed, in my opinion. That is the first part. Now, secondly, the most important part is the wind velocity and the seismic zone. Now those are specified in IS 875 part 3 or in IS 1893 part 1. Okay. Now whenever we are taking wind velocity and seismic zone from the Indian standard, then we cannot mix it up with the other country code because if we refer one individual country code, there are a lot of calibrations, there are a lot of engineering judgment which are being made. So according to me, if we design one structure with one country code in a holistic way, and then we design the similar structure with the different country code, again considering the all different clauses of the different country code, then there may not be much difference according to me. But if we mix up both the code, then there is a possibility of getting into very high conservative or unconservative error, because the calibration is happening in the entire process. The overall philosophy could be different. So that's why I have mentioned here that once we take wind velocity and seismic zone as per the Indian standard codes, then further load combinations and analysis design procedure shall be followed as per the Indian standard code only. And that's what I mentioned here, that it's quite dangerous to mix different country codes for the design. One more point which I mentioned here, that factor of safety depends upon a quality of raw material, quality of execution, etc. So it may happen that in our country code, the factor of safety or maybe a little bit higher probably with respect to the developed country code, wherein the practices relatively better in terms of quality control, or let's say the quality of execution, etc. And one more part related to interface and reference of the other relevant Indian standard codes. Okay. So once we take up few data from the Indian standard code, then again there are references given to the other relevant Indian standard code. So with this, if you are following only one set of document, then it is better for the design. Otherwise, there is a possibility of major error according to me. Okay. So these are the few reasons I have mentioned that why we should consider IS 800 2007. Okay. Now, once we talk about IS 800 2007, then this is the question coming up. That is a design considering IS 800 2007 is uneconomical. So let me quickly share my experience with respect to IS 800 2007. As I remember, it was for the first time in 2008 when we designed the entire structure using IS 800 2007 code. And then we were claiming at that time that this is the first structure or first project being designed considering all different clauses of the code using the limit state design method approach. But while working on the other project in the gradually we realized that there are few clauses, there are few parameters which we didn't understand properly when we designed it for the first time. So in 2011 I was designing, or rather I was involved in very big structure which is main powerhouse, and the tonnage was in the range of 5,000 metric ton. So we generated a kind of in-house exercise, because there was always arguments which were happening that with respect to IS 800 2007, our design is becoming heavy as compared to 800 1984 code. This was the arguments which we were receiving. Now always I was failed to understand that when we migrate from working stress design method to limit state design method, in fact the tonnage should be reduced, rather the design should be more optimized relatively with respect to working stress design method. So with that concept, we initiated number of in-house exercise, and I've started noting down my observation while working on the different projects. And this is one of the area which I have found out is that there are certain gap areas between IS 800 2007 and software. So when we talk about IS 800 2007, it is definitely, it is stringent in certain area with respect to 800 1984 code, because of, let's say, there are certain more research development which has happened, and based on our accumulated intelligence, we might have improved certain provisions. So in certain area it is more critical, but at the same time there are certain relaxation given in the code in 800 2007. But whatever relaxation given in the code, so part of those relaxation we are not able to capitalize because it is not properly implemented in the software. This was one of my major finding. uh, okay. And when we talk about software, it's not only one software, it is whatever popular software we are using, so it is not properly implemented in the software. So of course it's a big topic, and for this we created a specialized online course, Steel STR 001. So it's almost 1 month of course, and there are few participants who have joined today. They were part of this course, so wherein we discussed each and every clause of IS 800 2007 code, and then how to implement the same in the software StatPro and ETABS, and what are the major problems with respect to the cost optimization, or rather how we can do the cost optimization in the real structure. So that also we discussed it in detail. So I have just mentioned the link if you want to understand more details about the course, and let's say if you are interested to join the next batch, or if you are interested in recording of the previous batch, then you can just mention your details at this email address, and then we will get in touch with you for more details. Okay. So this is one part of IS 800 2007. Now this is the another common question which we receive, that is related to section 12 of IS 800 2007. So in section 12 also there is an interesting story. When I just started working for the first time related to IS 800 2007, my head of the department at that time just came to me and then asked me that, Bhavin, you just go through section 12, you understand, you decode, and then you explain it to the whole department. So that was for the first time in 2008 I started looking into the section 12, and let me tell you, till today I am just looking into the section 12 because still we are receiving number of queries. So before we get into any discussion for the section 12, just let me tell you that in NVC 2016 there are few important revisions are being made with respect to section 12. So if you have not seen those revisions, I'll recommend that you please go through it. So what are the common questions that whether section 12 is applicable to the structure? And let's say if section 12 is applicable to the structure under consideration, then which are the clauses which needs to be considered? That means, can we ignore certain clauses? And let's say if we decide that these are the clauses which we need to apply, or rather we need to consider for the structure, then how to implement those clauses in the software? So there are numerous questions, right? Of course, we'll not get into detailed discussion. So those questions also we discussed during that online course in detail, each and every question. But right now I'll be just quickly talking about overall philosophy of section 12 of IS 800 2007. So here I'll just quickly talk about the Northridge earthquake and steel structures. So generally whenever we are talking about steel structures, then steel structures are considered as relatively safe for earthquake resistant design, right? Because of its ductility of the steel structure. Whenever we say it is relatively safe, then we are comparing it with the reinforced concrete design, RCC structures, because it is more ductile. But this thought process was challenged during a Northridge earthquake of 1994. So what happened in that earthquake? Following that earthquake, a number of steel moment frame buildings were found to have experienced brittle fractures of beam to column connections. And the buildings which were damaged, if we quickly take statistics of those buildings, then heights were ranging from 1 story to 26 stories, and age of the building were spanning from old as 30 years to the structures which were being erected just only at time of the earthquake. So all structures were diversified with respect to the story height as well as with respect to the age of the structure. So it was one of the good thing that the no steel building suffered a catastrophic failure that took lives in that earthquake, but some were so badly damaged that they had to be completely demolished. Now, what was the type of damage? The weld connections cracked in the beams and columns of at least 90 such buildings. So whenever we are designing the steel structure with respect to earthquake resistant design, then always our expected damage is moderate yielding and localized buckling of the steel elements. But in reality, what happened during that earthquake, there was a brittle fracture at beam column junctions. So what went wrong with respect to the beam column junctions and the beam welding details? So right now I have just shown the typical welded moment connection which was used prior to 1994 earthquake. So so what happened? This detail was probably standardized maybe around 1950s 60s probably. And what has happened gradually when the time was passing, let's say 1950s 60s 70, then the quality of raw material was getting improved. So with that, the whatever yield strength which we are getting for the main sections, that was increasing. So that was increasing than the specified one. So with this, what has happened in the buildings, that the main column and beam sections, the flange, say a flange which I am highlighting here, that strength has increased with respect to this welding, because whatever standard details were specified, those electrode strength etc were not updated with respect to this increased strength, and this increased strength was beyond the specified normal value. So with that, what has happened, the welding has become the weak link in the structure. This was one of the reason. And again, if it is welding is inadequately or let's say improperly executed, then also it could become the weak link in the entire structure during the event of the earthquake. So what has happened after that? The concept of pre-qualified connections came. So thereafter, around 120 or 150 connections were tested on a full scale to derive the connection details which can be used readily by the practicing engineers, and that is being known popularly as a pre-qualified connections. So unfortunately, we do not have these pre-qualified connections detail in India. So whenever we talk about section 12 in IS 800 2007, then according to me, still there are lot many details or lot many improvement which is required. And one of the major thing is this connection detailing, because the first clause when we refer to the section 12 of IS 800 2007, if we talk about any frame, which is let's say OMF, SMRF, whatever frame we talk about, then the first clause is that the structure should be able to withstand the joint rotation of 0.02 radians or 0.04 radians depending upon the type of frames. And at that time it shall be shown that the structure is safe for the nonlinear displacement which is arising due to that joint rotation. Now in the analytical model, of course, we can establish that joint rotation, but in these pre-qualified connections, those joint rotations were also actually tested. So according to me, this is one of the big improvement area. And Let's hope that we get some more details related to the connection details. But this is the overall methodology or overall philosophy of the section 12. So in short, we can consider that section 12 is the ductile detailing for the steel structure. So there is more emphasis on the connection detailing and designing. So of course there is a section 10 which is for the connection design, but when we get into the section 12, there are more stringent clauses put up with respect to connection design and detailing. Okay. Now when we talk about section 12, there are few clauses, so which according to me, which are raising practical difficulties, which cannot be put up directly into the practice. So one of the example is let's say the base plate connection design, wherein we have to consider the plastic movement capacity based on the member which is provided, and with that the anchor bolt and the base plate size is becoming too large to be provided, or let's say it's becoming impractical for few projects. And there are a couple of clauses like this, for which still there are practical difficulties. So according to me, instead of ignoring those code or those clause directly, we must send and later to BIS with technical details along with the justification. And I think that would be the better approach. So we follow IS 800 2007, we follow section 12, and then wherever there is a practical difficulty, we must initiate communication with BIS along with the technical details with real examples, and along with our own justification that what kind of modification may be provided or may be done in the code. Now, this is the common question which few engineers asked, that who is responsible in case of unfortunate event of collapse of the structure. So if quickly we understand the hierarchy of typical project cycle as we just discussed before few minutes, there is an owner, right? And then owner is appointing structural consultant. Now structural consultant is preparing tender specification, and based on the tender specification, techno commercial evaluation will be done, and then PEB manufacturer will be on board, and thereafter PEB manufacturer will prepare the design basis report. Now for hypothetical case, let's say one of the structure has collapsed. Now what owner will say that I am layman, and that's why I have appointed a structural consultant. Okay. And what PEB manufacturer might say that we have followed the tender specification. Now since the tender specification itself was weak, and that's why this resulted structure was also weak, and then it could not withstand. So according to me, these are two critical document. One is the tender specification, which is being prepared by structural consultant, and of course this tender specification itself is a big area for the PEB structures, and one of the big area is the consideration of design standards. So that's what we are talking about today. Of course, maybe in the separate session we may take up other areas also gradually if you are interested. So according to me, the first important part is the definition of design standard, which needs to be mentioned very clearly in the tender specification. So according to me, it should be considered as a NBC 2016, because that is the latest document. And then the similar thing should be transferred into the design basis report. Okay, so according to me, this will be the couple of documents which will be scrutinized in this kind of an unfortunate event. Okay, so this document must be thoroughly examined before we put up for the execution. Okay, so few concluding remarks from my side, whatever we have discussed so far. MBMA is just a guideline according to me, and IS 800 2007 to be followed for design of steel structures in India. And we should never mix different country codes for design. It could result in a highly unconservative or conservative design. NBC 2016 is the latest document for design of steel structures as of today in India. Cost optimization is definitely possible with IS 800 2007, but for that definitely a few more manual intervention and few in-house exercises are required for achieving that cost optimization. Section 12 is for ductile detailing of steel structures, and as per my information now, one more draft code is already in progress, which is so we have IS 13920, and now there is another ductile detailing code which is specifically for the steel structure, which is being prepared. So draft is under preparation for the ductile detailing of steel structure, or we can say it is an extension of the section 12. And if there are any practical difficulties while using IS codes, then I would suggest that we must write letters to BIS along with the technical details and justifications. So that will be useful for the BIS also for releasing the amendment with respect to the input. And at the same time, you will also have a record with you that this is the practical problem, and you have already communicated with the BIS for the same. Okay, so this is what I just wanted to share with you. So I just attempted to share my quick thoughts on this subject, and now let us have open discussion on this important subject.